Well, good morning. My name is Sooriamurthi. I'm with the Information Systems program at Carnegie Mellon University. This is about a series of courses that we have at Carnegie Mellon that I teach on the general space of analytics. Okay? And in particular, it's about a new course that we created on big data and sustainability. Okay. So what I'd like to do is first start off giving a background of our IS program. Okay? IS at Carnegie Mellon is a little bit different from IS in many other places. Okay? I had a delightful period at the business school at Kelly where IS is how it normally is part of a business school. And it's similar to accounting and management and finance and so on. It's a major within the business school. But at Carnegie Mellon, it's a program of its own. And it's more like a software engineering program, okay, rather than a traditional IS program. So I'll talk about two courses that we have existing on analytics, okay, that we've taught a few times. And then a new course that we have created that I just mentioned on big data and sustainability. And the creation of this course was supported by IBM via a Watson Solutions faculty grant. Okay? And that was offered about a year ago. And based on our experience with that, we are creating a new version of the course that will be offered this spring in 2014. Okay. So here's the core IS curriculum in the program that I'm at. And our foundational courses on programming, okay, the people in IS, they take the exact same courses as the computer science students. So they either take 2 or 3 classes based upon their background, and they're the same classes that are taught by the computer science department, and then afterwards it forks. Okay, you can continue in IS or in computer science, okay, based upon which major, okay, you have been admitted to. To give a little bit about my own personal background, all of my academic degrees, from my undergraduate to my PhD, have been in computer science. Okay, and my research has been in artificial intelligence and case-based reasoning. And about a decade ago, I moved over to information systems, and particularly I was attracted by the applied aspect of it. And IS at Carnegie Mellon gives you a blend of both CS and the traditional IS, and it's been quite nice. So when you look at it here, you see that the number of core classes, okay, that constitute the IS program are fairly small. Okay, you go through 4 years. Okay, you start off with an IS course, a survey course in your second semester, and then you work your way through. Okay, IS, the milieu, gives you more of a traditional MIS course, and the application design and development, okay, that takes you through, okay, how do you use a database, how do you build a web application, and it's an intensive course, and for the last several years that's been based on Ruby on Rails. And the one that I've marked in green is the course that I teach, Fundamentals of System Development, where it's a blend of, okay, what was just mentioned, why do systems fail? Okay, looking at a variety of case studies, and I was telling my students that before the semester gets over, we'll have at least 2 more case studies, okay, that we can look at, and that turned out to be the case. Okay, so last fall during the elections, okay, there was another system that was of quite prominence that also had a catastrophic failure, and it's nice to be able to see these things in something that happened in the recent past, and to be able to study it and see that lessons for the last 20-odd years have not yet been fully absorbed, and similar mistakes are made. We study business process engineering, which what makes it different from a traditional software engineering course, and then we do the regular, okay, different types of agile practices, object-oriented analysis and design. And the whole idea of the course is to set up people for these 2 classes afterwards. In their junior year, okay, they work on a semester-long project. There are no classes, and they meet once a week with a faculty advisor. The team of about 4 or 5 people, they come up with an idea of their own, and they take it through the full system development lifecycle, where at the end of it, they have to have a prototype implemented and they have to have something that they can demonstrate of business value. The final course, the capstone experience for them, is 475, wherein we work with a client. We typically have about 10 to 12 teams, once again, of 4 or 5 students, and we work with a real client and take a problem that they have, and students have to liaison with the client and try to identify in what way technology could possibly help them address the problem that the client has. And it is a very nice experience for the students because this is where they come face to face with situations in the real world, and they're not as clean as it is as in other courses in academia. Now, what you see at the bottom are a whole bunch of electives, okay, that I teach in the general space of analytics. Okay, this starts off with a freshman class on puzzles, games, and problem solving. It's been a very popular class. Within a few minutes, okay, enrollment in the class is done, and usually the waiting list is twice as long as the enrollment in the class. And we focus on problem-solving skills. Okay, so we have a hierarchy where we're talking about project-based learning, problem-based learning, and then we view puzzle-based learning as a foundation for that. Subsequent classes that we've offered before are 2 classes on analytics and what we call as intelligent decision support systems, but for many purposes is a course on machine learning. Okay? Then after that is the big data and sustainability, and this new course that we're now in the process of putting together on big data analytics. Okay? Now these 4 courses, they do have a prerequisite associated with them, which is basically a foundation in programming and a background in statistics. Okay, they are normally junior level or senior level classes, okay, but by experience, okay, I found out that I don't put a restriction on the year in which you are in. I've had freshman students who've just come in do exceedingly well in these courses because they just come in with the needed background. So there is no, the only requirement is whether you have the skills, and it's not necessarily based upon what year, okay, that you're in. These 2 courses, the Applied Analytics and the Intelligent Decision Support Systems courses, these are standard fare, okay? So different types of business tasks, okay, what are the ways in which they can be accomplished? How can they add value to a business? And what differentiates this course from the other course is we look at the same business task again, but this time we're using a different set of technology, say like neural networks, okay, self-organizing maps, genetic algorithm, genetic programming, rule-based systems, case-based reasoning, okay, decision trees, okay, support vector machines, and so on. Okay, so the set of tools, okay, that we are using to analyze the same set of tasks that we looked at in the Applied Analytics class, that's what differentiates, okay, this course from the previous one. So we've been teaching these for a few years, and this was the basic analytical component that we had in our curriculum. Then IBM, okay, put out a request for proposals for a class that would incorporate ideas, okay, from Watson and see if we could fold that in. And the result of that, okay, we created, okay, this new course, okay, on big data and sustainability. Okay, so this was co-taught between me and another colleague, and we didn't want it to be just a class on big data, but rather to see, okay, in what area could we apply this? Okay, let's have an overarching theme, and then see how big data could be utilized in that context. Okay, so we looked around. We both had a common interest in sustainability, so we created a course, okay, with these 3 themes on big data, cognitive computing, since it was being sponsored by IBM, and sustainability. This was the first time that we were offering this course, and as was brought up during yesterday's session at 4 o'clock, this is new territory for a lot of people, including ourselves. And one opportunity that we have in the IS program and Carnegie Mellon in general is the ability to offer mini courses as pilots. Okay? So this is an undergraduate course. So we decided, okay, we'll offer it as an 8-week course, see how it goes, get some feedback from that, and then see, okay, how we can expand upon that. Okay, so for the rest of this, I'm going to be discussing what we did in this class, okay, which was last spring. Okay, what are some of the lessons, okay, that we took away from it, and how that's molding, okay, this new course that we're in the process of putting together. Okay, so this is what we wanted them to emerge with. Okay, just an idea of what big data is about. Okay, how it differentiates from other forms of analytics. Okay, in particular, okay, how it differentiates from cognitive computing, okay, which I was quite happy about because it blends in with my background in artificial intelligence. Wanted them to get hands-on experience with a couple of tools, Hadoop and BigQuery, okay, and we also use Google Trends. And at the end, okay, we wanted them to use IBM Watson, or the ideas of IBM Watson, in a problem for sustainability. Because of the recency in which this course is being offered, IBM Watson is not yet at a stage where it can be made available to academics yet. Okay, so we had an idea of what it is, what type of processing it can do, and so on. But using that as a framework, okay, can you identify a problem in sustainability and explore that? Okay. As I mentioned earlier, we didn't have any background prerequisites for this course. We just wanted people to have programming background, and we wanted people to have some exposure to statistics. The two classes earlier that we had on analytics, they were not prerequisites for this. And a result of this, okay, we were quite pleased because not only did we get IS majors, okay, we got people from business, we got people from humanities, okay, we got people from engineering. Okay, he didn't necessarily have the courses themselves, but had some background in this, and were, more importantly, were interested in exploring it. Okay, so that was the only prerequisite that we had. But we started off the course with laying a foundation so that we made sure that everybody was on the same platform. Okay, we started off with discussing a traditional analytics class, different types of tasks. And one of my favorite case studies is target ability, which people here would be familiar with, their ability to predict quite uncannily as to whether a woman is pregnant or not. And so using that as a case study, okay, gave us the foundation for analytics. Okay, and then okay, we moved on to big data. And one of the issues that I personally struggled with in academia is to get this notion of, well, how big is big data? Okay, when we say that, okay, we can toss out numbers like this, okay, and saying, okay, we're right now we're at the Zeta level, okay, which is like 10 to the power 21. Okay, the NSA may be the first customer, okay, that's at the Yotta level, okay, with their Utah data warehouse, okay, that's under construction right now. But how do we get a feel for that? Is there a different way in which we can measure that? And one thing that I'm also particularly interested in is outreach. Okay, I've done a bunch of outreach in different aspects, and we're right now in the process of seeing how can we do outreach on big data to high schools. Okay, and there was a nice presentation on that yesterday. Okay. And one of the things is to try to convey, like, how big is this? And one that I'm particularly fond of is this one over here. This is Carl Sagan's cosmic calendar. Okay, and many of you may be familiar with it. Just to recapitulate what it does is that it takes the creation of the universe from the Big Bang till today. And the moment that the universe was created is the first second after midnight of January 1. And right now where we are is midnight of December 31st. And the whole existence of the universe is encapsulated in that period, and 1 second translates to something like 434 years. Okay, so we're right now just about a second before, and that's what, rather a second before where we are right now is where most of the developments that we are familiar with have happened. Now this is a period of only 14 billion years. Okay, we're going much, much, much beyond that. Okay, so how can you get a better feel for that? Okay, there are different analogies, okay, that we use for that. Okay, and I can discuss about that in more detail. But this is one way in which we get a feel of where you can express, okay, the size of things. Okay, the other thing that constantly wrestle with is this just like old sheep in new clothes, or is there something really different? Okay, over the years, okay, there's been online analytic processing, then it was called analytics, then it was called data mining. Right now, what's popular is big data. Okay, it's sort of like, okay, when I started doing computing in the mid-'80s, it doesn't matter what you did, it was object-oriented. Okay. And same thing now. Okay, this tag gets stuck on it, and the thing that always bothers me is that, okay, is there really something that you can show by putting in more data, you are getting something that is qualitatively different? Okay, and there are a few examples of that. The one that I'm particularly fond of is Google Translate, okay, by the work of Peter Norvig, where you've been to translate.google.com, okay, you'll see their ability to translate between close to 60 languages. And the way in which translation used to happen before was, okay, you sat down, okay, you studied the syntax of a language, you came up with the semantics, and you tried to do a mapping from one to the other, and you were only able to get so far. And what they were able to do is take an entirely different approach and say, okay, here's a paper, okay, there's a handful of people in this room, okay, you'll probably understand the script on the left. That's my native language, okay, in Tamil. And that's a translation of, okay, the Gettysburg Address. And you take a newspaper, here's a newspaper article that occurs in Tamil, here's a newspaper, okay, the article that occurs in English. Let's see if we can do word matching between them and try to figure out, okay, whether this word corresponds to this word. And they just threw a huge amount of data at it that it ended up beating everybody else, okay, who was out there trying to do machine translation. The algorithms were relatively simple, but it was the volume of data that ended up making the difference. And of course, Google doesn't have any shortage for that. And they were able to leverage that, okay, to really make, okay, take machine translation to a level that it has not been at before. Okay, we're talking about an order of magnitude improvement. Okay, so these are the examples that I think would really make the value of big data evident, saying that, okay, it's this huge amount of data that really, okay, pushes something forward and gives you a different qualitative experience. Okay, so regarding exercises and assignments in class, okay, what we had them do, and this is like 8 weeks, okay, we had exercises, okay, in Google Trends. Okay, one that was very popular was Google Flu Trends, okay, which is a special case of this, and the ability of Google to be able to predict, okay, when there was going to be an outbreak of flu about 2 weeks before even the CDC was aware that there was an outbreak. And trying to see, okay, when were certain things trending, okay, at different times of the year. Okay, Google has their version of NoSQL, okay, which I call as BigQuery, and data sets that they have, and let's explore those and see, okay, what type of analysis that we can do. And then we also worked with Hadoop. Now, given the duration of the course, okay, and also the background of the students, and given that this is an exploratory pilot course, okay, what we did was use the streaming interface of Hadoop. Most of our students are familiar with either Python or with Ruby, and with basically any language, as you may be familiar with, okay, you can do a streaming interface with Hadoop, and you don't have to get into the nitty-gritty details of trying to express it in Java. A Java program that may run to 100+ lines would probably get squished to less than 10 lines if you were to express it in Ruby or in Python. And that was something that enabled us to be able to do a lot more in the time that we had, rather than if we were to go into core Hadoop programming. Okay, but I'll talk about the next course, okay, that we have in mind where we're planning to change some of that. Okay. The next component that we had was cognitive computing. And these are two situations that IBM has done a remarkable job with. In the early or the mid-90s, okay, is when Deep Blue, okay, managed to beat the world, okay, chess champion. And finally, after 40 years, one of the holy grails of artificial intelligence research, okay, was finally achieved, to be able to get a machine to play computers at a level more significant than a person. And next was cognitive computing. Okay, now if you're familiar with the way in which chess playing programs work, and particularly how Deep Blue works, it's no way similar to how people play chess. Okay, it's a pure engineering approach. Let's bring brute, okay, force to bear, and with, of course, a lot of chess techniques. But the way in which it plays is not related to a human, whereas cognitive computing, okay, as is embodied in the current version of Watson, is trying to mimic the way in which humans, okay, would reason. Okay? And we're familiar with, okay, the stellar effort that they did in February of 2011, okay, when once again another thing that seemed to be within the realm of humans, okay, succumbed to machines, and Watson beat the chess champions. Okay? So we spent time, okay, discussing the architecture of Watson, okay, looking at some evolving case studies. Okay, remember this was spring of 2012, and it was just then that IBM was fielding for various applications of Watson into different domains, and one domain where they were exploring it was in healthcare. Okay? Now, at this context, okay, if there's anybody who's interested in doing outreach and dealing with big data and something like healthcare, one example that I use in order to get a flavor for the type of reasoning that Watson does is what's sometimes called as situational puzzles. That's something familiar with? Okay, here's an example of a situation puzzle there. Okay, say you're walking on the side of a mountain and you see that there's a cabin there. You open the cabin and there are 3 people who are dead. What happened? Then what characterizes Watson is the ability to come up with various hypotheses and then to query their knowledge sources further to establish probabilistically which of these various hypotheses, okay, may be right. And that's the characteristic of situation puzzles. When you look at them, you really have no idea what to do. So you start asking questions to the person who has posed the puzzle. You formulate, okay, 3 or 4 hypotheses, and you try to gather evidence for that before you finally solve it. And that's sort of a fun way of expressing the type of reasoning that Watson is capable of doing. Okay. Then it also came up during the presentation yesterday at 4 o'clock that this is a space that is really challenging to offer a course. Okay? I think one of the boons and the banes of our profession is that things change a lot, which is good. We don't get bored. But then the challenge is that things change a lot. Okay, we got to keep on track of this. So we had the good fortune that there were various other colleagues who did this more for a living, okay, than what we did, and we were able to utilize their expertise in terms of guest lectures. Okay? One, okay, that we had was a person come in from IBM's Smarter Planet initiative and discuss ways in which IBM is using large amounts of data to get more effective performance. Okay, one example, okay, is the one that you see over here, is the Rochester campus of IBM, where the buildings have been instrumented with sensors, and it monitors whether like certain rooms or buildings are being utilized, and if they're not, accordingly adjusting temperatures, power consumptions, and so on for that room. This one down here is the School of Architecture of at Tulane University, and they were able to leverage the catastrophic effects of Katrina, and when buildings were destroyed, I said, okay, when you're going to build it up again, okay, let's see if we can instrument them, thereby trying to make them more energy efficient. The one that I'm particularly fond of is the one up over here, and this is a system that is deployed at the Los Angeles school system, where there are about 700,000 students. And an issue was, and this is across the whole Los Angeles school system, where something will break. Okay, there's a pipe that's broken, a toilet isn't working, or so on like that. And one thing that students do have are phones. So what they did was to enable students, whenever they saw that something was not right or so, they gave the ability to be able to indicate, okay, what was not right, and just based upon the position at where they were able to localize it. And if too many calls were to come in from that particular region, then they knew that was something serious and they had to address it. And they basically crowdsourced maintenance notification. Okay, and it was left to the students to do this. The other case study that we had to discuss in class, okay, this is from a person, okay, who explores, okay, the value of a Twitter feed for disaster response. Okay? And this is an interesting statistic here. It's given about like 20 million tweets, okay, that happened during the time of Sandy, even if 0.001%. That means add 2 more zeros to that. Okay, even if that small amount were accurate, okay, there's a huge amount of noise that happens with Twitter feeds. But even if that small amount was viewed to be relevant, then we're talking about somewhere of the order of 15,000 words, and that translates to 25 pages of disaster information. Okay, where has something gone wrong? Who needs help? Okay, how can we get help to you? And so on, like that. So Twitter is an enormous source, and of course, other areas where it has been utilized, as in the spring uprising and various other contexts, things that we are familiar with. Okay, but applying it to disaster relief, okay, is a relatively new area. And one of the key challenges is that when you do get a Twitter message, trying to identify what is the location of a geolocation of a tweet is a challenge, and part of the discussion, okay, revolved around the way in which research, okay, was progressing for that. Okay. The next is we had the good fortune of a person who was actually on the Watson team as a faculty member in the computer science department. So in the lecture that he gave, he was able to give us a behind-the-scenes look of what happened during the development of Watson. And he was primarily involved in developing, okay, this unstructured information management architecture, okay, and his work predates Watson by about 10 years. And that formed the core of the natural language processing component of Watson. Okay, so not only did we get a chance to see not just the evolution of Watson, but also to see how did the people who were involved in the construction of Watson, how did they work? Okay, they had so I'll just give one example of it, a form of extreme programming, except that, okay, it wasn't done by 2 people, but rather it was a huge, okay, screen, something like this, where a whole bunch of people were actually sitting and coding on it at the same time, and they can see the state of the whole system at the same time. So in about 4 years, okay, we're talking about software disasters, in 4 years they were able to pull off a remarkable achievement. And what were the software development strategies that they used for that, okay, was something, okay, that was quite useful, okay, to our students. And the researcher was then able to discuss, okay, what his current work is in extending the work of Jeopardy Watson. The last discussion that we had was different from the previous ones, is when we think of big data, probably one of the first tools that pops to mind is Hadoop. Okay? And the Pittsburgh Supercomputing Center, okay, they do have Hadoop machines there, and they were kind enough. They were the people who hosted the cluster that we used in our course. But another area that they're working in a lot is that not all data is amenable to the divide and conquer type processing of Hadoop. And one in particular that isn't is graph data. So if you got different pieces of information and they are related in different ways by expressed as edges, then Hadoop doesn't turn out to be a useful architecture for that, and there are special purpose architectures for that type of processing. And this course happened in spring, and we were fortunate that just that previous fall, the Pittsburgh Supercomputing Center got this new machine called Sherlock, okay, which was specifically meant for graph analytics. Okay, it came out of Cray Research. Okay, that's now known as Cray. You flip it around, they're called YARC systems. And had a discussion of the types of problems that graph analytics can solve that traditional Hadoop architectures are not able to address. Okay. So now with this background, it ties into the core theme of the course. Okay, we had lectures on sustainability and the importance of that. And the term project, okay, that they had, the course project, I should say, since it was only an 8-week course, was take the capabilities of Watson. Okay, we've studied some examples of what Watson is able to do. Assume you had that, okay, and you had to come up with a proposal for applying Watson-style technology for problems related to sustainability. What would you do? What was nice in that this is like, okay, turning students on, okay, tossing a piece of red meat and say, go. Okay, and they really sunk in their teeth with it and came up with some really interesting examples, okay, right from protecting the rainforest, okay, so certain exotic plants from which medicines are being extracted, okay, can continue to exist. Two, and you can't see it over here that well, is monitoring a particular type of disease that bats have called white nose syndrome. And if it's not contained, then it decimates the bat population. Okay, so how can Watson-type reasoning technology, and basically you formulate some hypotheses and then you try to establish the validity of these hypotheses by exploring data sources and establishing different probabilities for these hypotheses until one bubbles up to the top. Okay, so they had to come up with proposals and make presentations, and we had people from IBM there to listen in on their presentations and give them feedback. So that was the culminating exercise for the course, and it tied in these components together, which is big data, cognitive computing, as well as sustainability. Okay, so that's the course, okay, that we've just completed last spring. Okay? And it's a course that we would not have been able to have offered without the support of many people. And we're quite grateful, okay, to IBM for the support and the grant for the course, as well as the personnel, okay, that they, we were able to ask, okay, to give talks to us. Our other CMU colleagues and also people, colleagues from the Pittsburgh Supercomputing Center who not only hosted our Hadoop cluster, okay, but also shared their practical experience in doing big data. So that was spring 13. Okay? So we sat, we looked back at it, and we said, well, should we do this again? And personally, okay, something that I tell my students is that whenever I teach a class, I'm guaranteed that at least one person will have a really good time. That's me. Okay? So I said, okay, we got to do this again. Okay, so me and my colleague, okay, said, let's do it again. Okay, and this is the next version of this. And we're taking a slightly different take on this. Okay, so this would be maybe of particular interest to people in academia. Okay, remember that the earlier course was an 8-week course. So what we've done is we have made it into a full semester course, but it's as 2 8-week components. Okay, so the first part of it is just a tooling part. Okay, so you learn more about Hadoop. Okay, you learn more about various other technologies that are out there, BigQuery and so on, and we work with smaller data sets. So the end of that, the idea is that you have hands-on experience with some tools. Okay? Amongst the things, okay, that we're looking into experimenting with is to try to flip the class. Okay, and we're having it as a 3-hour session once a day in a week. So the first part would be a discussion rather than, okay, it also came up yesterday that this is not something that, okay, you want to stand in front of students, okay, lecturing. So flip it and have the students, okay, take the second part of it and demonstrate, okay, what it is, okay, that they have done. Okay. The part that we're still toying with, okay, and this is something where we're going to cap enrollment. We haven't yet figured the number out, but it'll probably be somewhere between 10 and 15. And even though it is going to be taught as an undergraduate class, we're thinking of taking it as a graduate seminar. Okay? And one thing that we really want is people, okay, to have a good experience out of this. Okay? And what happens often, okay, if we think back to our undergraduate days, is that we did an assignment, we tossed it over the wall, okay, the professor graded it, and back came a grade over this wall, and that was it. Okay? But rather what we are thinking about is that there are only 2 grades that are possible. You either get an A or get an incomplete. Okay, so we give out these assignments, they do it, they send it back, we're not happy with it, goes back to them again, work on it more. Okay, until they iterate on it, until we're pleased with the quality of the work. Okay, and if they decide to throw up their hands and so on, then that's fine. Okay, they can get an I and they can move on there. Okay, but that's the idea that we are moving towards. So trying to raise everybody to the level of, okay, it's not a one-shot thing. You can do something, submit it. We're not happy with it. You can resubmit and keep on working on it. The second 8 weeks is for those who would like to continue would be to take raw data. Okay, and we have access to a number of data sets, okay, from the Energy Institute and so on, okay, that we have some relationship with. Take this raw data, take the tools and technologies that you learned in the first half of the course, and see, okay, what you can do with this. Okay, so it's going to be highly exploratory, and we're not anticipating that it be like a regular class, but rather it be group meetings with the students to see, okay, what it is that they have done with the data sets that they are exploring. Okay, so that's where we're heading towards for spring of 2014. Okay, so with that, I'll pause and hand it over to the next speaker.